using the product rule. Let's do some examples of using the product rule. So here are 3 examples. We want to differentiate f of x equal to x squared plus 1 times x squared minus 1. We want to differentiate g of t equals t cubed minus t plus 1 times e to the t. And we also want to find the derivative of h of z equals z times the square root of z. So we're trying to get better at this, and so I would suggest you trying to do these on your own first before watching me do it and get lots of extra practice. That's the goal here, is to get you to the point where this is second nature. So first, let's try to differentiate f of x equals x squared plus 1 times x squared minus 1. You should recognize this as one of the examples that you did in class previously. But we want to now be able to do this with the product rule. So the product rule says that if I want to differentiate f of x, that means that we can first take the derivative of x squared plus 1 and then multiply times x squared minus 1. Okay, x squared minus 1 gets left alone. What we take the derivative of is x squared plus 1. Now that's not the whole product rule. Of course, we now have to add x squared plus 1 times the derivative of x squared minus 1. I'm sort of running out of room here. Okay. So now that we know what we need to do, now we need to just do it. So we take the derivative of x squared plus 1, and we get 2x. And now we leave x squared minus 1 alone. So we get 2x times x squared minus 1. Notice that's the derivative of the first factor of my quotient, of my product. And we leave the second factor alone. Then we add that to x squared plus 1. That's the other factor of the product, times the derivative of x squared minus 1, which is also 2x. Now, if you remember, in class, we got 4x cubed as the derivative of this product because we multiplied it out. We distributed x squared plus 1 and x squared minus 1. And we got that the derivative was 4x cubed. It should not matter how you take the derivative. The answer should always be the same. So let's check. Let's go ahead and expand and make sure we do get the same answer. So if we multiply through by 2x, we get 2x cubed minus 2x. And then we expand out x squared plus 1 times 2x. We get 2x cubed plus 2x. And then 2x cubed plus 2x cubed is 4x cubed. And negative 2x plus 2x is 0. So there indeed our derivative is 4x cubed. Okay, so let's try the next one. I want to differentiate g of t equal to t cubed minus t plus 1 times e to the t. So again, this is a product. We're multiplying 2 functions. Our first function is t cubed minus t plus 1, and our second function is e to the t. Okay, so if we want to take the derivative, we're looking for g prime of t. And so the first thing that we need to do is take the derivative of t cubed minus t plus 1, take the derivative of that, times e to the t, plus, then we're going to leave t cubed minus t plus 1 alone, and then multiply by the derivative of e to the t. This is my intermediate step. I wrote it a little bit differently this time so that you could see it written a different way. Both ways are correct. So now I actually need to take the derivative. So I need to take the derivative of t cubed minus t plus 1. So we get 3t squared minus 1. All of that times e to the t. Yes, my parentheses are necessary. Plus, now I leave t cubed minus t plus 1 alone. And And now I take the derivative of e to the t, which of course is e to the t. Okay. So this is it. This is my answer. If you really want to, you can rewrite this, because of course everything has a factor of e to the t. So we can just add these two coefficients of e to the t, and we would get t cubed plus 3t squared minus t, and then I'd have minus 1 plus 1, so times e to the t, and there would be my derivative. Okay. And then one last one. Let's find the derivative of h of z, which is z times the square root of z. Find the derivative doesn't mean anything different than differentiate. I'm just trying to give you different ways of saying the same thing. Okay. Of course, you might look at this and say, okay, h of z is, well, that's just z to the 3/2. I don't need a product rule. I can just use a power rule. So h prime of z is 3/2 z to the 3/2 minus 1, which is 3/2 z to the 1/2, or in other words, 3/2 times the square root of z. Well, maybe you didn't realize that you could have used a power rule, and you said, I want to use the product rule. Okay, no matter what, you should get the same answer. You should get 3/2 square root of z. Let's make sure we can get that answer with the product rule. Okay. So we start with h of z equals z times the square root of z. So we have two functions here we're multiplying together. So z is one function, square root of z is the other function. So to find the derivative, h prime of z, we take the derivative of z, which is 1, and then we leave square root of z alone. So 1 times the square root of z, plus, now we leave z alone, and we multiply times the derivative of square root of z, which is 1/2 z to the 1/2 minus 1, which is z to the negative 1/2. In order to do that, I use the fact that the square root of z is the same as z to the 1/2 power. Okay, well, that doesn't look like 3/2 times the square root of z, so let's try to make it look more like that. So 1 times the square root of z is the square root of z. And then here we have z divided by 2 square root of z, or maybe a little bit easier to work with, z over 2 z to the 1/2, which is square root of z plus, well, z divided by z to the 1/2 is z to the 1/2 over 2. Of course, z to the 1/2 is the square root of z. So I have square root of z plus 1/2 square root of z, which is 3/2 square root of z. And I got the same answer, which I should have. It doesn't matter which way we take the derivative. They should all amount to the same answer. Okay. More with the quotient rule, and then combining them with other rules and further videos.